rock-forming minerals. So there are only about 30 minerals that are common. We said there are about 3,000 minerals that have been identified, but only about 30 of those are actually common. And then 8 to 10 of those are what we call rock-forming minerals because they make up most of the rocks in Earth's crust. And those minerals are listed over here in Table 1. So we have mica as one example. We have feldspar as another one of our rock-forming minerals, olivine, quartz, amphibole, pyroxene, garnet, and calcite. Those are all our rock-forming minerals. Now, silicon and oxygen are the most common elements in Earth's crust. Silicon is about 27.7% of the elements in Earth's crust. Oxygen is 46.6% of the elements in Earth's crust. And then the third most abundant is actually aluminum at 8.1%. So silicates are the most common class of minerals. We haven't talked about it yet, but silicates have silicon and oxygen in it. Well, if you look, that includes mica, that includes feldspar, that includes olivine, that includes quartz, that includes amphibole, that includes pyroxene, that includes garnet. In fact, all of these except for calcite. Calcite is a carbonate. It's the only one of the rock-forming minerals that is not a silicate. So how do we form minerals? So we get minerals from magma. So magma is molten rock below Earth's surface. It becomes lava if it comes out of a volcano or something that ends up on the Earth's surface. But if it's below the surface, we call it magma. It's less dense than surrounding rock because it's hotter than the surrounding rock. So it rises into the cooler layers of the Earth. And then it cools and it crystallizes. Elements present in the magma determine which minerals form. So if you don't have the elements present to form a specific mineral, that will not form. So you get minerals that incorporate the elements that are actually present in the magma. And then the cooling rate determines the size of the mineral crystals. So if we have slower cooling, we have larger crystals. If we have faster cooling, we have smaller crystals because they don't have, if it's cools slower, the crystals have more time to form. The atoms have more time to arrange themselves in these nice crystal structures and these repeating patterns. If they cool too quickly, then they don't have time to arrange themselves. So our granite over here, so this granite, cools very slowly, so it gives it this appearance with all these speckles. All these speckles are different minerals that are in the granite. Okay, so you got these lighter minerals, you got the darker minerals, and you got these sort of tan minerals in the middle. You can also get minerals from solutions. So minerals are often dissolved in water. When no more of a substance, which is the solute, can be dissolved in water, the solution is saturated. Then adding more solute, cooling the solution, or evaporation of some water creates a supersaturated solution. So anything that increases the concentration of the solute, again, like adding more solute, cooling the solution, which basically warmer solutions can hold more solute than cooler solutions. So if you cool it, it can't hold as much of whatever you're dissolving. Or evaporating some of the water, which basically increases the concentration of the solute. Those all would create a supersaturated solution, and at which time the atoms are going to bond together and then mineral crystals are going to precipitate out. So I guess I should talk a little more about solutions, but a solution is if you have your solvent, which is usually water, then you have your solute, which is what you are dissolving in it. So maybe that is salt. Okay, so if you put the salt in the water, the salt is the solute, the water is the solvent. Okay. Minerals also form when water evaporates, and these are called evaporites. This is like if the water completely evaporates, you're left with evaporites. And this is basically Yellowstone National Park. This is some of the warm springs there and a lot of the minerals that have precipitated out as the water is evaporated from these hot springs.